Thank you for tuning back into the Automation Podcast. Shawn Tierney here from Insights. And this week on this show, I meet up with Henrik Pedersen and Jacob Abel to learn all about virtual PLCs from OTee. That's OTEE. And I just thought it was very interesting. So if you guys have ever thought about maybe running virtual PLCs to test some processes out, I think you'll really enjoy this. With that said, I want to welcome to the show for the very first time, Henrik and Jacob. Guys, before we jump into your presentation and learn more about what you do, could you first introduce yourself to our audience?
Yeah, absolutely. So my name is Henrik. I am the co-founder CEO of OTee, a new industrial automation company that we're really glad to present here today. I have a background from ABB. I worked 11 years at ABB. In terms of education, I have an engineering degree and a master's degree in industrial economics. And yeah, I'm excited to be here. Thanks, Shawn. And I'll pass it over to Jake.
I'm Jacob Abel. I'm the principal automation engineer at EdgeNot. EdgeNot is a systems integrator focusing on edge computing and virtual PLCs. My background is in mechanical engineering. I'm a professional control systems engineer, and I have 13 years experience in the machine building side of industrial automation, specifically in oil and gas, making flow separators. And I'll hand it back to Henrik here.
Okay, great. So OTee, we are a new industrial automation company, the new kid on the block, if you will. We're a startup. So we're only started about 3 years ago now. And we focus solely on virtual PLCs and the data architectures allowing you to integrate virtual PLCs in operations. And, you know, some of the listeners will be very familiar with this first thing I'm going to say, but I think it's valuable to just take a little bit step back and remember what has happened in history when it comes to IT and OT and what really happened with that split, right? So it was probably around around 1990s where the domain computer science were really split into these two domains, the IT and OT, and that was kind of natural that happened because we got on the IT side of things, we got internet and we got open protocols, and we had the personal computers, and innovation could truly flourish on the IT side. But whereas on the OT side, we were kind of stuck still in the proprietary hardware software lock-in situation, and that has really not been solved, right? That is still kind of the situation today, and this was obviously what also brought me personally to really got really super motivated to solve this problem and really dive deep into it. And I experienced this firsthand with my role in ADD and how extremely locked we are at creating new solutions and new innovation on the OT side. So we're basically a company that wants to truly open up the innovation in this space and make it possible to adopt anything new and new solutions that sits above the PLC and that integrate effectively to the controller. So I have this this slide that kind of illustrates this point with some historical events or at least some big shifts that has happened. And already mentioned a shift in 1990s, and it wasn't actually until 2006 that Gartner coined this term OT to explain the difference, really, what has happened. And as we know, IT has just boomed with innovation since the 90s, and OT is slowly, incrementally getting better, but it's still the innovation pace is really not fast. So this is also, of course, illustrated with all the new developments in Gen AI and agentic AI, MCP, and things like that. That is kind of booming on the IT side of things, and yeah. So, but we do believe that there is actually something happening right now. And we have data to kind of show for that. Like the large incumbents are now working on this as well, like virtual PLCs, software-defined automation, and all kinds of exciting things going on the OT side. So we do believe that we will see a shift, a true big shift on the OT side in terms of innovation, really the speed in which we can improve and adopt new solutions on the OT side. And this is kind of exemplified by like what is the end game here? Like you could say that the end game could be that IT and OT once again becomes the same high-paced innovation domain, right? But then we need to solve those underlying problems, the infrastructural problems that are still so persistent on the OT side of things. The fine point of this slide is to just illustrate what is happening right now with like cloud solutions for control is actually happening. Virtual PLC, software-based automation, AI is happening all at once. And we see it with the big suppliers and also the exciting startups that's coming into this space. So I think there's lots of great excitement now that we can expect from the OT side in the next few years.
Yeah, I want to just add, just for those listening, add a little context here. If we look at 1980, why was that so important? Why is this on the chart? And if you think about it, right, we got networks like Modbus and Data Highway in 1978, 79, 80. We also got Ethernet at that time as well. And so we had on the plant floor field buses for our controls, but in the offices, people were going to Ethernet. And then when we started seeing the birth of the public internet, right, we're talking about in the 90s, people who were working on the plant floor, they were like, no, don't let the whole world access my plant floor network. And so I think that's where we saw the initial, the divide, it was in 1980, it was a physical divide, just physically different topologies, right? Different needs, right? And then and as the internet came out in the early 90s, it was now like, hey, we need to keep us safe. We know there's something called hackers on the internet. And I think that's why, as you're saying, in 2006, when Gartner coined OT, we were seeing that there was this hesitant to bring the two together because of the different viewpoints and the different needs of both systems. So I think it's very interesting. I know you listeners, you can't see this, but I kind of wanted to go back through that and kind of give some context to those early years. And like Henrik says, now that we're past all that, now that we're using Ethernet on the plant floor everywhere, right? Almost everywhere, on all new systems, definitely. That becomes the right now on the today on the chart. And I'll turn it back to you, Henrik.
Yeah, absolutely. I just want to echo that. I think that there are really good reasons for why this has happened. Like you could argue that innovation could flourish on the IT side because there was less critical systems, right? Less, more. You can do fail fast, and you can do you can test out things on a different level. And so there's really lots of good reasons for why this has happened. But we do believe that right now there is some really excitement around innovation, the OT side of things, and this pent up kind of, I wouldn't call it frustration, but this pent up potential, I think is the right word, can be kind of unleashed in our industry for the next decade. So we are like, this is really one of the key motivators for me personally. It's like, I truly believe there's something truly big going on right now, and I do encourage everyone listening, like, get in on this. Like, this is happening. And be an entrepreneur as well. Like, build your company, you could create something new and exciting in this space. I think that this is a time that there hasn't been a better time to create a new technology company or new service company in this space. So this is something at least that motivates me personally a lot. So let me move over to kind of what we do. I mentioned that we focus solely on the virtual PLC. This is now presented in the slide for those that are listening as a box inside a open hardware. We can deploy a virtual PLC on any ARM 32 and 64-bit processor and x86 64-bit with the Linux kernel. So there are lots of great options to choose from on the hardware side, and yeah. So you can obviously, when you have a virtual PLC, you can think a bit new in terms of your system architecture. You could, for instance, deploy multiple virtual PLCs on the same hardware, and you can also think about it like you can use a virtual PLC in combination with your existing PLCs, and could work as a master PLC or some kind of optimization deterministic controller. So it's really just opening up that that architectural aspect of things. Like you can think new in terms of your system architecture, and you have a wide range of hardware to choose from. And yeah, so the flexibility is really the key here. Flexibility in how you architect your system. That CPU that you deploy on will obviously need to be connected to the field somehow, and that's through classical remote I/O connections. So we currently support Modbus TCP and Ethernet IP, which is kind of deployed to our production environment, as it's called. So moving on to the next slide, like this is kind of the summary of our solution. We have built a cloud native IDE, so meaning anyone can basically go to our website and log into the solution and give it a spin. And we'll show you that afterwards with Jake. And the system interacts through a pub/sub data framework. We use a specific technology called NOTS for the pub/sub communication bus, and you can add MQTT or OPC UA to the pub/sub framework according to your needs. So, and from that you can integrate with whatever other software you might have in your system. So we have these value points that we always like to bring up. Like this obviously breaks some kind of vendor lock-in in terms of the hardware and the software, but it's also our virtual PLC is based on 61131, so it's not a lock-in to any kind of proprietary programming language or anything like that. There's obviously the cost element to this, that you can potentially save a lot of cost. We have that verified with some of our customers that they estimate to save up to 60% in total cost of ownership. There's obviously one part is the CapEx side, and the other part is the OpEx. And this data framework, as I mentioned, this in itself is future-proof to some extent. You can integrate whatever comes in a year or in a few years down the line. And there's the environmental footprint argument for this, as you can save a lot on the infrastructure side. We have one specific customer that estimates to save a lot and this particular point is really important for them. And then final 2 points is essentially that we have built in a zero trust-based security principle into this solution. So we have role-based access control. Everything is encrypted end-to-end, automatic certification, and things like that. The final point is that this is the infrastructure that allows you to bring AI and the classical DevOps, the thing that we're very used to in the IT side of things, like you commit and merge and release instead of the traditional way of working with your automation systems. So I know this is pretty much like the boring sales pitch slide, but yeah, I just wanted to throw this out there for the guys that there is some intrinsic values underneath here. The way the system works, you will see this very soon through the demo. But it's basically you just go to a website, you log in, you create a project. In there, you would create your PLC program, test, you code, you simulate. You would onboard a device, so onboard that Linux device that you want to deploy on. This can be as simple as a Raspberry Pi, or it can be something much more industrial grade. This depends on the use case. And then you would deploy services like, as I mentioned, MQTT and OBC UA, and then you would manage your system from the interface. And I have this nice quote that we got to use from one of the customers we had. This is a global automotive manufacturer that basically tells us that they really highlighted the speed in which you can set this up as one of the biggest values for them, saving them a lot of hours in setting up the system. So I also wanted to show you a real, this is an actual real deployment. It was deployed about a year ago. And this is a pump station or a water and wastewater operator with around 200 pump stations. They had a mix of Rockwell and Schneider PLCs, and they had very high upkeep, and they were losing a lot of data from these stations because they were connected over 4G. When the internet was a bit poor, they lost a bit of data in their SCADA system, so they had these data gaps and things like that. So pretty, standard legacy setup, to be honest. Quite outdated PLCs as well. So what they did for the first pump station was they removed the PLC. They put in a Raspberry Pi for like €60 or like $70. Connected it to a remote I/O Ethernet IP module they had in the storage, and deployed this data framework as I'm showing on the screen now. So that was the first station they put online, and they chose the Raspberry Pi because they thought, okay, this is interesting, but will it work? And then they chose a pump station which was really just poor from before, so they had very little to lose to deploy on this station. So yeah, this has been running for a year now without any problems on a Raspberry Pi. We have obviously advised against using a Raspberry Pi in a critical environment, but they just insisted that's what they wanted to do for this first case.
And I'll back that up too. Your generic off-the-shelf Raspberry Pi is just like a generic off-the-shelf computer. It's not rated for these type of environments. Not that all pump houses are really bad, but they're not air conditioned. And I think we've all had that situation when it's 120, 130 out, that, off-the-shelf computer components can act wonky, as well as when they get below freezing. So just wanted to chime in there and agree with you on that. For testing, it's great. But if you're going to leave it in there, if you were in my town and you say you're going to leave that in there permanently, I would ask to have you assigned somewhere else in the town.
Yeah, exactly. No, so and that point is also illustrated with the second station they brought online. So there they chose a much more industrial grade CPU that was much cost a bit more, but it's more suited for the environment and yeah. So this was I can disclose it was a Bayer Electronics CPU. So yeah, and they reported some good metrics in terms of like the results. They said around 50% on the hardware, 75% on the management of the PLC system. So this relates more to that they have a lot of driving out with the car to these stations and doing changes to their systems and updates. They no longer have any data loss. It's local buffer on the data framework. They've increased tag capacity with 15x, resulting in 455x better data resolution and a faster scan frequency. And this is actually on the Raspberry Pi. So just think of it as the kind of the lowest quality IT off the shelf computers are able to execute really fast or fast enough for these cases. So Shawn, that was actually what I wanted to say, and also, yeah, we are a startup, but we do have 50 users now in 57 different countries across the world, and it's really cool to see our technology being deployed around the world, and yeah, I'm really excited to get more users in and hear what they think of the solution. So yeah. I'll with that, I don't know if Shawn, you want to shoot any questions, or if we should hand it over to Jake for a demo.
Yeah, just before we go to Jake, if somebody who's listening is interested, this might be a good time. It said that you already talked about being cloud-based. It's OTEE. So Oscar Tom Edward for the name of the company. Where would they go if they like what Jake's going to show us next? Where do they go to find out more?
Yeah, so I would honestly propose that they just reach out to me or Jake on one of the QR codes that we have on the presentation. But they can also obviously go to our website, otee.io, otee.io, and just either just log in and test the product, or they could reach out to us through our website, through the contact form. So, yeah.
Perfect. All right, Jake, I'll turn it over to you.
Thanks, Shawn. Fantastic stuff, Henrik. I wanted to take a second, too, to kind of emphasize some of the technical points that you presented on. First, the fact that you have the built-in zero trust cybersecurity is so huge. So, I mean, the OT cybersecurity is blowing up right now. So many certifications, lots of consulting and buzz on LinkedIn. I mean, it's a very real concern. It's for a good reason, right? But with this zero trust built in to the system, I mean, you can completely close up the firewall except for one outgoing port, and you have all the virtual PLCs connected together, and it's all done. There's no incoming ports to open up on the firewall to worry about, that security concern. It's basically like, you've already set up a VPN server, if you will. It's not the same, but similar. And, taking care of that connection already. So there's an immense value in that, I think.
And I wanted to add to the zero trust. We've covered it on the show. And just for people, maybe you've missed it, with zero trust is you're not trusting anyone. You authorize connections. Okay. So by default, nobody's laptop or cell phone or tablet can talk to anything. You authorize, hey, I want this SCADA system to talk to this PLC. I want this PLC to talk to this IO. I want this historian to talk to this PLC. Every connection has to be explicitly enabled and trusted. And so by default, an integrator who comes into the plant, he can't do anything, because in a zero trust system, somebody has to give him and his laptop access to specific things. Maybe he only gets access to the PLC, and that makes sense. Think about it. Who knows whether his laptop has been? I mean, we've heard about people plugging into the USB ports at the airport and getting viruses. So it's important that person's device or a SCADA system or a historian only has access to exactly what it needs access to. Just like you don't let the secretary walk on the plant floor and start running the machine, right? So it's an important concept. We've covered it a lot. And Jake, I really appreciate you bringing that up, because zero trust is so huge, and I think it's huge for OT to have it built into their system.
Yeah, absolutely.
I wanted to highlight too, Henrik mentioned that the backbone of the system is running on a technology called NATS. That's spelled NATS. And why that's important is this is a lightweight messaging service, and it's designed to send millions of messages per second. That's opposed to, probably the best Modbus TCP device that you can find. You might get a couple hundred messages through per second. It's millions of messages per second. It's, especially with, we're dealing with AI, machine learning, training models. I mean, we're data hungry, right? So this gives you the backbone too. It's like it can push an immense amount of tag data, with ease. I think that's another really important point. With that, though, I'll get on to the demo.
Oh, that's great. We do see that, Jake, that most of our customers report on that, 400 or 700x better data resolution, and so it's a step change for the data resolution there. Yeah.
Excellent. So one of the things that I personally love about OT is how quickly you can get into the PLC once everything's set up. So this is OTee's website, obviously, OTee.io. So once you're here, you just go to log in, and that brings in the login screen. Now I'm using my Google account for single sign-on, so I can just click continue with Google, and this brings me into the main interface. And another thing that I love is that it's very simple and straightforward. And simple is not a bad thing. Simple is a good thing. I mean, the way that things should be is that it should be easy, and the finer details are taken care of for you. So right here we have our main project list. I just have this one benchmarking program that I've imported in here. And you also have device list, just a test device that I've installed the runtime on. Just real quick, you have a Martha, the AI assistant, in the corner here, and the documentation guides is up here, so you can get help or look into reference material very easily. It's all right there for you. So I'm going to open up this program here. So just a quick tour here. Right up here in the top left is basically where most everything's done. So if you click on this little down arrow, you can choose what virtual PLC runtime to attach it to. I've already attached it to the device I installed the runtime on. You can add, a new program, driver, function blocks, custom data types real quick here. Compile your program, download it to the device, check the release history, which is really, really great, because you can go into release history and you can revert to a prior version very easily. We got built-in version control, which is another great feature.
I can also just comment on that, Jake, that we do have a in the quite short-term roadmap to also expand on that with Git integration that a lot of our customers are asking for. So yeah.
Awesome. Yeah, I mean that's another very hot topic right now. It's getting the revision control systems as part of at least the textual programming languages. So we have a few like housekeeping things here. I mean, you can delete the program, export it. It's a good point here is that OT complies with the PLC Open XML specification. So you can import or export programs in this XML format, and it should work with solid majority of other automation software out there. If you need to, you want to transition over to OT, you can export it from your other software and import it rather easily. Got your program list here, and just the basic configuration of, you can add global variables that you want to share between the different programs and POUs, or, change the cycle rate of the periodic tasks, add more tasks. Let's just jump into this program here. The OT system uses the IEC 61131-3 standard structured text. So here's just a little quick benchmark program that I've been using to do some performance testing. So you have the code right here, obviously, and on our right, the variable list. It's very easy to add a new variable and pick out the type. You can set a default value, add some notes to it. super easy. So let's go online. So you have these little glasses up here in the top right. You display live tag values. And so it's grabbing from the runtime that's running and plopping it right in here in the editor, which I love the way it's displayed. It makes it, it's one of the question marks is if you're doing structured text instead of ladder logic, like how it's going to show up and how readable is it going to be. I think the text, like the color contrast here helps a lot. It's very, very readable and intuitive. And we also have the tag browser on the right-hand side. Everything is organized into, different groups. There's the resources and instances that you've set up in the configuration tab. So by default, the tags are all listed under there. And here too, you can set tag values. Doing some performance testing, as I said. So this is recording some jitter and task time metrics. And that's really it. That's the Cloud IDE in a nutshell. Super easy, very intuitive. I mean, there's zero learning curve here.
For the audio audience, just a little comment here. First of all, structured text to me seems to be like the most compatible between all PLCs. So, everybody does ladder a little bit differently. Everybody does function blocks a little bit differently. But structured text, and again, I could be wrong if you guys think out there in listening, think I'm wrong about that. But when I've seen structured text and compared it between multiple different vendors, it always seems to be the closest from vendor to vendor to vendor. So I can see this makes a great place to start for OT to have a virtual PLC that supports that, because you're going to be able to import or export to maybe your physical PLCs. The other thing is I wanted to comment on what we're seeing here. So many of you who are familiar with structured text, you may have an if then else or an if then, and in it you may have like tag X equals either some kind of calculation, maybe Z times Y, or just maybe a constant. But what we're seeing here is as we're running, they have inserted in a different color the actual value of, let's say, tag X. So in between, right next to tag X, we see the actual value changing and updating a few times a second. And so it makes it very easy to kind of monitor this thing while it's running and see how everything's working. And I know that's huge. And I know a lot of vendors also do this as well, but I love the integration here, how it's so easy to see what the current values are for each of these variables. And I'll turn it over to you, Henrik. I think I interrupted you. Go ahead.
Yeah, no, I was just going to comment on that. Jake said, like, this is the PLC editor, and the next big feature that we're releasing very soon is essentially the service manager, which is the feature that will allow our users to deploy any kind of service very efficiently, like another runtime or an OPC US server or an MQTT server or whatever other software components that you want to deploy, like a NOT server or things like that. So, and that's we were really excited about that, because that will kind of allow for a step change in how you kind of orchestrate and manage your system, and you have a very good overview over what's going on with versions of the different software components running in your infrastructure and your devices and things like that. So we're really excited about that it's coming out. And it might be that actually when this episode airs, who knows if it's done or not, but we're very close to release the first version of that. So excited about that.
Now I have a question for you guys, and maybe this is off topic a little bit. So let's say I'm up here in the cloud, I'm working on a program, and I have some I/O on my desk I want to connect it to. Is that something I can do? Is there a connector I can download and install on my PC to allow the cloud to talk to my I/O? Or is that something where I have to get a local, like we talked about, those industrial Linux boxes and test it here with that?
Yeah, so I think what you're after is like the I/O configuration of if you want to deploy a driver, right, or like a Modbus driver, and how you figure out the system, right?
Yeah, because this is in the cloud. It's not on my desk. The IO is on my desk. So how would I connect the two of them? How would I, is that something that can be done?
Yeah, yeah, exactly. That's essentially the, I think, Jake, you might just want to show how you deploy a driver, right?
Sure, sure. And I just want to take a second to clarify. It's something that kind of comes up often, and I don't think it gets cleared up enough. Is that so? We have this Cloud IDE here, so you can open this from anywhere in the world. But the virtual PLC runtimes get installed on computers, preferably very locally. On the machine, on the factory floor, something like that. I've got an edge computer right here. Just as an example, I mean, this is something you would just pop in the control panel and you can install OT on this. So to answer your question better, Shawn, to get to the remote IO that you need essentially, or actually in the case of this has onboard IO. You're looking at connecting with Modbus TCP, Ethernet IP. I know that a lot more protocols are coming, Profinet. So how you would do that is you have that plus sign up here and add a driver config. We're just going to do Modbus real quick.
Mhm.
And we want to add a TCP client. So you can name the client. Tell it how fast to pull, any delays, put in the IP address. Just an example, do the port number if you need, and then add your requests. You have support for all the main function codes of Modbus right here. Read holding, read input, write multiple coils, all that good stuff. Tell it address, how many registers you want to do, timeout, slave ID. And then, once you've done that, so let's say, I'm going to read 10 holding registers here. The table on the right, auto updates. You can do aliases for each one of these. You can just do register one
Mhm.
as an example.
It's showing, just for the audio audience, it's showing the absolute address for all these Modbus variables, and then it has the symbols, and he's putting in his own symbol name. It has a default symbol name of symbol dash something, and he's putting his own in, like register one, which makes it easier. Yeah.
Good point. Yeah, good point. Thanks, Shawn. So yeah, once you put in your requests and you can throw in some aliases for the different registers, you can go back to your program and here's this sample variable that I just added from earlier. You can, the registers are 16 bits. So I'm going to select an int. And what you can do here now is select those Modbus requests that you just set up. So it automatically maps these to those variables for you. So that way you don't have to do anything manual, like have a separate program to say, this tag equals, register 40,001. It's already mapped for you. So that's essentially how you would connect to remote IO is just add a client in the driver configs and fill in all your info and be off and running.
That's excellent. I really liked how you were able to easily map the register to the Modbus value you're reading in or writing to your variable, so you can use it in your program. That was very easy to do.
Oh yeah. That's like I said, that's one of the things that I love about this interface is that everything is just very straightforward. It's super easy to just stumble upon whatever it is you need and figure it out.
And just to add to kind of your process here, is like once you have created that connection between the IO and the program, you basically just compile it and download it to the runtime again, and it executes locally based on
Nice.
Oh, right. Good point. Yeah. Of course, after we add something, we do have to re-download. So
Very interesting. Well, that answers my question.
I think that's about it for the demo. I mean, unless Shawn, you have any more questions about the interface here?
No, it looked pretty straightforward to me. Henrik, I didn't know. Did you have anything else you wanted to discuss while we have the demo up?
No, nothing related to this, except for that, this is probably something that's quite new in the OT space, is that this is a software service, meaning that there are continuous development going on and releases and improvements to the software all the time. Like literally every week we deploy new improvements, and what I typically say is that, like, if you sign up with OT, what you'll experience is that the actual software keeps on becoming better over time, and is not going to become outdated. It's going to be just better over time, and I think that's part of what I really loved about the innovation happening around IT, is that has become the new de facto standard in how you develop software, and great software. And I think we in the OT space, we need to adopt that same methodology of developing software, something that continuously becomes better over time.
And I would just say, if you're on the OT side of things, you want to be in 61131-3 languages, because these are things that your staff, your electricians and technicians and even engineers, should be getting up to speed on. I know at the automation school, we're teaching structured text. And so easier, I look at this and I'm like, this is a lot easier than trying to learn C+ or JavaScript. So in any case, I think, if it's an OT side, real IO control, real control system or data collection, very important, mission critical data collection, then, I'd rather have this than somebody trying to write some custom code for me and, using some kind of computer language who doesn't understand, the OT side of things. So I could definitely see the advantage of your system, Henrik.
I also wanted to say to that, like I do not believe the EIC standards in general will disappear. They exist for a very good reason, right? They exist to standardize, to ensure safety and determinism in this. So I don't think they will disappear, but there are obviously advances now with AI and things like that can help us create these things much faster and much more efficient and things like that. But the EIC standards, I think, will be there for a very long time. Obviously, the 64099 standard is really exciting, and we believe that can be, that can clearly be there, but it's still an EIC standard. So,
I think what we're going to see is a lot more libraries fleshed out. There'll be a lot less writing from scratch. We've interviewed on the History of Automation podcast, we've interviewed some big integrators, and they're at a point now, 20, 30 years on, that they have libraries for everything. And I think that's where we'll see, much like the DCS, I think vendors went 2 years ago. But I still think there's a reason for these languages. There's a reason to be able to edit things while they run. There's a reason for different languages for different applications and different people maintaining them. So I agree with you on that. I don't think we're going to see the end of these standard languages that have done us very well since the 1970s.
I just want to add a bit on there about Shawn. You mentioned doing less code. I did show earlier in the bottom right hand corner here, we have our little AI assistant, Martha. I don't believe the feature has been released yet. Henrik, correct me if I'm wrong, but I know one of the things that's coming is AI code generation, similar to that of Claude or ChatGPT. So it's going to, you can open this guy up here. Right now, I think it's just for help topics, but you'll be able to talk to Martha and she's going to generate code for you in your program there, all built in.
Yeah, that's coming really fast now. So it's not been implemented yet, but it's right around the corner.
Yeah, and it's not going to be able to. You're not going to be able to hook a camera up to it and like take pictures of your machine and say, okay, write the control code for this. But if you had a process that had 12 steps in it, the AI could definitely help you generate that code and other code. And we'll have to have Henrik and Jake back on to talk about that when it comes out. But it's going to be able to save you, reduce the tedious part of the coding. If you need an array of so many tags and so many dimensions, or the stuff that it would just be the typing intensive, it's going to be able to help you with that, and then you can actually put the context in there, just like you can pull up a template in Word for a letter, and then you can fill in the blanks, and of course AI is helping make that easier too. But in any case, Hendrik, maybe you can come back on when that feature launches.
Yeah, absolutely. And I'm also excited about just a simple use case of translating something, right? Translating your existing, let's say if it's a proprietary code or something like that, like getting it standardized and translating it to the EIC 61131 standard, for instance, or so the obviously AI is like perfect for this space. There is no doubt. And it's like that's also why I'm so excited about like what's going on at the moment. It's like there's so much innovation potential on the OT side now that with all these new technologies.
Yeah, absolutely, absolutely. Well, gentlemen, was there anything else you wanted to cover?
I think just one final thing from me is like we thought a lot about it like before this episode, and we thought like let's offer the listeners something of true value. So we thought after this episode launch, we want to offer anyone out there that's listening a free, completely hands-on trial of our technology in their environment or on their Raspberry Pi or whatever. So just reach out to us if you want to do that, and then we'll get you set up for testing this, and it's not going to cost you anything.
Well, that's great. And guys, if you're listening, if you do take advantage of that free trial, please let me know what you thought about it. But Henrik, thank you so much for that offer to our listening audience. Guys, don't be bashful. Reach out to him. Reach out to Jake. Jake, thank you for doing the demo as well. Really appreciate it.
My pleasure.
Any final words, Henrik, before we close out?
No, it's been great being here, Shawn, and thanks for having us.
Well, I hope you enjoyed that episode. And I want to thank Henrik and Jacob for coming on the show, telling us all about OTee Virtual PLCs, and then giving us a demo. I thought it was really cool. Now, if any of you guys take them up on their free trial, please let me know what you think. I'd love to hear from you. And with that, I do want to thank OTee for sponsoring this episode so we could release it completely ad-free. And I also want to thank you for tuning back in this week. We have another podcast coming out next week. It'll be early because I will be traveling and doing an event with a vendor. And so expect that instead of coming out on a Wednesday to come out on Monday if all goes as planned. And then we will be skipping the Thanksgiving week, and then we'll be back in December. And then we have shows lined up for the new year already as well. So thank you for being a listener, a viewer, and please, wherever you're consuming the show, whether it's on YouTube or on the Automation blog or at iTunes or Spotify or Google Podcasts or anywhere, please give us a thumbs up and a like or a 5-star review, because that really helps us expand our audience and find new vendors to come on the show. And with that, I'm going to end by wishing you good health and happiness. And until next time, my friends, peace.